Have you ever wondered how DEET is made? This smelly liquid is in pretty much every bug spray and keeps us free from all these nasty ticks and mosquitoes. I mean, such a vital part of modern life, produced on a gigantic scale, can't be that hard to make yourself, and that's exactly what I set out to find. I figured that after using my amateur chemistry skills to cook this stuff up, I would then make it into a banned 100% DEET bug spray and test it out on this jar of mosquitoes. The problem with all this, however, is that I severely underestimated just how hard making DEET is, and it kind of humbled me as a chemist. No. Because let me tell you, the amount of work and soul I put into this project is just insane, and the end result was much better than I ever expected. All this started roughly 6 months ago, and funnily enough, I got the idea for this project while chasing a mosquito after it woke me up at 4 in the morning, which I guess makes this video one gigantic revenge story. To figure out how to make DEET, I first had to look up some more information on it, since apart from its cryptic name, I didn't know much about it. Turns out its real name is N-diethyl metatoluamide, which honestly sounds more at home for a chemist, and this is its molecular structure, which is basically a representation of how it looks on the atomic level. To understand how I am going to make it, I used something called retrosynthetic analysis, which sounds kind of fancy, but boils down to heating the molecule in half and finding out if the resulting pieces are available for me to buy or make myself. In this case, I need something called diethylamine, which I could easily buy online, as well as this little goober called m-Toluic acid. Buying it turned out to be much harder than I expected, which is why I figured I'd take a shot at making it myself. After a bunch of research, I figured I could do it using one of my favorite sources of laboratory chemicals, which is 5 liters of paint thinner I found in my garage. Now, I couldn't find any exact procedure for this, so to pay tribute to amateur chemistry as a whole, I decided to just wing it. To start, I added a bunch of distilled water into a flask, followed by 100 ml of paint thinner, and got everything onto a hot plate with stirring. Then I began slowly adding in potassium permanganate, which gave everything this lovely purple color, and in theory is the only thing required to turn paint thinner into m-Toluic acid. I had to add a ton of this stuff, so the resulting solution looked more black than purple, and to initiate the reaction, I set it up for a reflux, which is just an elaborate way of saying that I can now boil the solution without any paint thinner escaping into the air. As the flask warmed up, the reaction just took off, making this beautiful rainbow crust appear out of nowhere and producing some weird sounds. Even though it should produce quite a bit of m-Toluic acid, this reaction has many problems, mostly owing to potassium permanganate's really violent nature and the fact that my paint thinner contains a ton of chemical junk that could screw everything up. Nonetheless, I really hoped that I would get something out of this, and after refluxing the solution for a few hours, the purple color disappeared, signaling that the reaction was done. To extract my product from the reaction mixture, I first filtered off the black byproduct and then got everything into a separatory funnel. It allowed me to get rid of the surprisingly large amount of unreacted paint thinner which floated on top of the water layer. Then, to precipitate my product from this yellowish solution, I poured in some hydrochloric acid. No. This turned the solution into a foam volcano, making it erupt with a ton of some gas, and at the time I had no idea what happened here. After cleaning up as best as I could, I got the solution into a bigger beaker and continued adding the acid. The foam, of course, struck again, but this time it wasn't nearly as bad, in the end becoming a white slurry, hopefully containing lots of product. To pull it out, I really didn't want to use regular filtration, since these slurries are an absolute nightmare to filter, so instead I came up with this genius idea inspired by my grandma's cooking. It actually worked fine, with a cheesecloth allowing me to recover and initially dry most of the precipitated product, but what really scared me was the amount I ended up with. After drying everything out, I got like 2 grams of this white solid, which was really bad. What's even worse, I am pretty sure this isn't even m-Toluic acid. Judging by the amount of unreacted paint thinner, as well as all the mystery gas from before, I figured that the potassium permanganate reacted with only a small bit of the metaxylene present in paint thinner and turned most of it into carbon dioxide instead of m-Toluic acid. The last nail in the coffin for this reaction was a melting point test I carried out using some vegetable oil and a hot plate, which confirmed that what I have here certainly isn't m-Toluic acid and just some heavily oxidized byproducts. I honestly felt pretty devastated that all this work and my dream of making DEET from paint thinner ended up as 2 grams of unidentified white powder, but honestly, this is what chemistry often looks like. That's exactly why I turned to the only place that could cheer me up, and that is the chemical industry. More precisely, the Indian chemical industry, which just so happens to produce the finest m-Toluic acid. I could afford it only thanks to my patrons, and with this part of DEET finally secured, it is time to actually make some. This is where the real fun begins, since m-Toluic acid and diethylamine don't just combine to form DEET, and I have to force them to bond against their will. This is where thionyl chloride comes in, and it's basically the chemical equivalent of a monkey with a machine gun. For one, it's extremely hard to find, dangerous, toxic as hell, and boy does it smell. It also doesn't ask for permission to react with something, it just does, in the process creating gases that can easily melt your lungs. That's why I recently picked up this bottle of it, and it's just the thing I need to force DEET into existence. To begin, I got 30 grams of m-Toluic acid into a flask and then poured in 28 grams of thionyl chloride, which is a small excess. Since I like my lungs like they are, I did this all under a fume hood, and before the reaction picked up, I assembled the flask into a reflux with a twist. You see, because the gases thionyl chloride generates aren't good both for my lungs and my fume hood, I decided to destroy them as soon as they form by leading them into this inverted funnel trap filled with a sodium hydroxide solution. The reaction between thionyl chloride and m-Toluic acid started before I even turned on the steering, and as you can see by the big air bubbles coming from the trap, a ton of hydrogen chloride and sulfur dioxide gas is being generated. Along with the gases, which feel like the main product of this reaction, something called m-Toluil chloride is also formed, and it's basically an angry form of m-Toluic acid, to which thionyl chloride gave some of its destructive power, annihilating itself in the process. This acid chloride is just angry enough to later turn into DEET, and I honestly think that this transfer of chemical anger is cool as hell. Also, this whole reaction went surprisingly smoothly, and with the help of a hot water bath and a can of cooked peas, everything was done reacting in no time, leaving me with this nice brownish liquid of quite pure m-Toluil chloride. I didn't measure the yield or admire my product for too long, since it quickly spoils in moist air, and I was really eager to turn it into DEET. I again assembled the flask into a chunky setup, this time consisting of a reflux and this 2-necked adapter. It is all supported by 2 cans of delicious cooked meat, and the second neck allows me to easily add more ingredients to this witch's brew. Still, I would prefer to use an addition funnel, but sometimes you just can't get what you want, so manual addition it is. I first charged the flask with 50 ml of a solvent called DCM, which helps ease any sudden temperature spikes and tends to make things go much smoother. Everything was now set for me to finally combine the acid chloride with diethylamine to form DEET, however this wasn't as straightforward as it may seem. It's because when diethylamine reacts with the acid chloride, a bunch of hydrogen chloride is also generated as a byproduct, and it has this annoying property of combining with diethylamine to form a salt, which just sits around doing nothing. I didn't want to have only half my diethylamine available for the reaction, so I had to think of some way to deal with the salt formation, and commercially, this seems to be commonly done using a solution of sodium hydroxide. In my humble opinion, this method is trash, and luckily there is always the option of just using twice as much diethylamine or adding an unreactive hydrogen chloride scavenger like the incredibly stinky triethylamine. Oh, oh god! It's like rotten fish mixed with a landfill. A whole landfill of garbage. God, it smells bad. I wanted to have my patrons decide what route to take, and under a recent update video, one of them suggested using triethylamine, so I thought, why not? I started slowly adding 22 grams of it into the acid chloride solution, and because there was some hydrogen chloride already present from before, this cool mist of triethylamine hydrochloride appeared. Then I began slowly pouring in 17 grams of diethylamine diluted with some DCM, and this addition generated a ton of heat, making the solution instantly boil.
Wow.
It prompted me to set up an ice bath for the flask and add the diethylamine really slowly using a pipette, which, while tedious as hell, ensured it didn't all blow up. When I was done, the reaction mixture looked like some mango pulp from all the precipitated salt, and to drive the reaction to completion, I swapped out the ice bath for a hot water one. After refluxing the mixture for an hour, everything was definitely done reacting, and I ultimately ended up with this thick slurry containing my precious DEET. I was really happy that I got this far without anything blowing up or gassing me, and you'd think that the hard part is over, but boy, this is only the beginning. Purifying DEET from this forbidden mango juice is something that I intensely feared since starting this project, since it's just so freaking hard. Luckily, the first step isn't all that bad, and I just need to separate my DEET from all the solid junk. I used vacuum filtration, which dealt with it in no time, and now it's time to wash away any acidic or basic impurities that may be present in my DEET-containing solution. For that, I must use the one and only separatory funnel, and while I am normally fine using this for separating liquids, using them to wash something is out of my comfort zone, to put it lightly. It just always ends in intense frustration, and the first wash where I used a dilute sodium hydroxide solution perfectly displays that. After pouring everything into the funnel and shaking it while venting it compulsively so that the cap doesn't give up, I set it back on the stand, only to find that the layers magically disappeared. Only after waiting half an hour and then squinting my eyes, I could barely see this faint line separating the layers, and after draining off the DEET one, instead of a nice and clear liquid, it looked like orange juice. This whole washing step basically made my product way dirtier than it was, and the best thing is that I need to wash it 3 more times, with the next washing featuring dilute hydrochloric acid. This time the layers were a little easier to see, but instead of separating them right away, I had to repeatedly wiggle the funnel, which looks kind of weird, but is vital to dislodge those tiny acid droplets that stick to the funnel's walls. Anyway, I then drained off my ever dirtier product layer and washed it yet again, this time with a saturated table salt solution, to try removing traces of water and acid left over from the previous washings. Then, just for good measure, I washed everything with salt water once again, and thank God this thing was now over. As expected, my DEET solution still looks horrible and smells even worse, which is weird because I always imagined that at this point I could detect at least some of this trademark smell of bug spray. This is another reason why I have to purify this stuff further, and the last trick up my sleeve is distillation on steroids. To carry it out, I got this flask and filtered my DEET solution into it through some cotton. I also used anhydrous sodium sulfate to pull out any remaining moisture, and both these things combined made the solution much prettier. I then assembled it into a distillation setup featuring an oil bath, and since DCM boils at just 40 degrees Celsius, I was able to quickly remove pretty much all of it. Now, you'd think that with all the DCM gone, I can just crank up the heating and distill over some clean DEET, but in reality this is beyond challenging. DEET boils at around 300 degrees Celsius, and if you heat it anywhere near that, it will just refuse to exist and break down on the spot. That's why there are no examples of anybody distilling it on the internet, and from what I could find, I am the only person crazy enough to try it. The reason why it's not outright impossible is that if I get my distillation set up under vacuum, the boiling point of DEET goes down proportionally to its strength. Sadly, since DEET's boiling point is just so stupendously high, no ordinary vacuum pump will do, and the one I normally use can only serve to remove the last bits of DCM from the system. To truly vaporize DEET, I need a pump with some more kick, and thanks to a few months worth of my Patreon's support, I've been able to buy this monster. It weighs like 20 kilos and is a 1 horsepower 2-stage rotary vane vacuum pump. Unlike the other one, it requires special vacuum pump oil to work and can supposedly reach pressures down to 0.3 pascals, which is some hella fine vacuum. However, since it's still on the cheaper end of such pumps, if you let it pump on full power, it basically becomes a giant smoke machine, and connecting it to the distillation setup was one of the sketchiest vacuum hose jobs on the planet. Still, I even managed to install this valve here, which is incredibly important as it prevents me from putting the vacuum on too quickly and making the setup implode. As one great movie said, implosions are ugly, and this is especially true in chemistry, where if you don't treat vacuum with enough respect, glassware can basically turn into thousands of sharp pieces and launch directly into your face. That's why I used the least amount of glassware I could. I also specifically chose a round bottom boiling flask and used thick-walled, sturdy receiving flasks. Overall, I was quite nervous about this whole thing, and when the big vacuum pump was up and running, I desperately waited for the DEET to start boiling. As time went on without anything happening, the anxiety piled on, and I thought that maybe the pump was trash after all, or I didn't grease the joints well enough. But right then, I saw a vapor front traveling up. It quickly made its way to the condenser to end up as this oily liquid dripping into the receiving flask. I was just ecstatic because this meant that my cursed distillation setup actually works and that I succeeded in making DEET after all. Oh yeah, baby. Now, excuse me for bragging, but once it got going, the distillation went perfectly, with the DEET steadily boiling at around 130 degrees Celsius, and it didn't take long for most of it to come over. Once there was mostly just black tar left in the boiling flask, I stopped the distillation and recovered my product. Considering that this was my third vacuum distillation, I was hella proud of myself and amazed at how the pump held up so well. When it comes to the result of this whole endeavor, it's a slightly yellow oil, and this, ladies and gentlemen, is pure DEET. Before any real testing, I just had to see how it smells, and let's just say I was quite surprised.
Oh, this isn't actually anything like the commercial DEET. It doesn't have any of this punchy chemical smell, and instead smells like some kind of citrus fruit mixed with garbage. Still, the smell is incredibly weak, so I'm really surprised.
Turns out that in every bug spray there is some kind of added fragrance, which is quite weird, since they could as well make it nearly odorless. Still, it's nice that I could find this out myself, and when it comes to the yield of this whole process, based on the starting m-Toluic acid, it comes down to around 70% or nearly 29 grams. Honestly, this is nice, especially considering all the washings, the tar left over after the distillation, and an incident involving unexplained loss of product, definitely beyond my control. With pure DEET finally here, I think it's time to do what I dreamed of from the beginning and make the world's strongest bug spray. Compared to the horrors I experienced before, this was a walk in the park, and all I did was measure out 20 milliliters of my DEET and pour it into a spray bottle, which I then labeled with an image that says it all. This is officially 100% DEET bug spray without any weird fragrances or additives, and I think that this stuff is banned in my country. However, I don't care, and now I finally have what it takes to get revenge on these annoying flying death machines. The way I collected a whole jar of mosquitoes was pretty genius, since instead of just randomly spying on each one of them, I used the fact that they love to spend the winter in my basement. There are probably close to 1,000 of them here every year, and with the help of a small jar and a piece of paper, I proceeded to capture around 50. I then transported them all to my winter lab where I recorded this project, and at first they all resided in this tiny jar, which made most of them die of overcrowding, making me transfer the remaining survivors to a bigger jar, complete with state-of-the-art ventilation and a food source in the form of a cotton pad soaked in sugar water. Like this, the 10 or so mosquitoes seemed to be happy and constantly flew around, making this ungodly sound, which kind of gives me PTSD. I planned to do a big test of my DEET with all of them, but the synthesis took me quite a long time, and in the end these guys had to sit in the jar for 2 months. That's why it's my pleasure to introduce you to this little fella who turned out to be the only survivor of the catch of 25. It proved to be the most resilient of all the mosquitoes and is probably ravenous, since despite being able to survive on sugar, female mosquitoes need at least 1 blood meal to be healthy and reproduce. This means that I will at least be able to test if my DEET can prevent the mosquito from biting me, and I first used this ingenious contraption to transfer it into a smaller jar. Then I applied some of the pure DEET bug spray onto my forearm, and then tried to tip the jar with the mosquito onto the sprayed spot, but of course it escaped. I was miraculously able to trap it again using a flask, and after getting it back into the jar, I repeated the test with more precision this time. After flying around for a while, the mosquito did end up landing on my skin, which worried me a little, but then it suddenly died.
What the hell? How? What?
This was, well, unexpected, since DEET doesn't actually kill mosquitoes, but only severely confuses them. I don't complain about such an outcome, however, and it means that even though pure DEET bug repellent doesn't stay on skin any longer than the commercial stuff, it is more effective, at least for close encounters. In the end, I think that making my own DEET was beyond worth it, and I literally feel like I experienced personal growth throughout this whole project, with the final outcome being just magnificent. Also, this video was made in collaboration with my supporters on Patreon, who not only chose it from a whole set of projects, but also financed the whole thing. Through the exclusive update videos I recorded, I got the amazing opportunity to listen to their feedback, and I want to dearly thank each and every one of them for their continued support. If you also want to support my channel by becoming a patron, there is a link in the description, and I have some really cool content there, so I recommend you check it out. Anyway, I hope you all enjoyed this video, and if you did, please consider subscribing, liking and sharing it with a friend. Thanks for watching and see you in the next one.